I want to share with you today is the work that we've been doing on Mantis AI. So I'm Greek, and Mantis in Greek is the divine. It's someone who can see, it's a seer, somebody who can see the future and who can see beyond. So in the concept of can we now enable this cartography of ideas, can we map the space of not just land, but concepts? The same way that you're using Google Maps to navigate physical space, and it's unthinkable to go in a large forest at 6 p.m. without a compass, without a GPS, without some bird's eye view of the landscape. In the same way, it should be unthinkable to navigate the space of ideas without a map, without a compass, without a landscape. So what we're doing is we're using AI to map the space of ideas, to map this cognitive space, this conceptual space, and we're using that technology to enable innovation, to enable collaboration, to enable next frontiers in education, and to change the space of productivity. And the way that we think about this is that many times there's a serendipitous encounter between two people who are passing each other and happen to work on the same thing. How many times have we had a transformative idea due to just chance? Well, we don't want to leave serendipity to chance. We want to enable serendipity by mapping this space, this cartography, systematically. So as Einstein would say, any beginner can collect data and facts, but it really takes an expert to understand how every one of these facts fits into the landscape of ideas. If you read any one paper, yes, sure, you can decipher it, but an expert in the field knows exactly the landscape of where that paper fits. And that's the underlying fabric of knowledge space. Again, very beautiful picture of Albert, very beautiful quote, but it's obviously not by Albert himself. It's just a landscape of ideas, if you wish. So if you look at cartography, it has really changed the shape and the face of the world. This is a map of ancient Greece, and by understanding the landscape, Leonidas and his 300 army was able to push back 10,000 soldiers from Xerxes and the army of the Persians. How did he do that? By understanding the landscape, by understanding Thermopylae, the passage through which they could be stopped. And we can do the same to understand the landscape of ideas, to understand what are the islands that are being uncharted, what are the empty gaps, and what ideas lie in those gaps. If I could have every concept, every innovation, every patent, every grant, every scientific paper, every poem, every love story in this landscape of all of humanity's ideas, I want you to challenge yourselves of what would you do with this? So here are 3 million articles by the New York Times. And you could basically spend decades developing an ontology for every New York Times article, every news article, and painstakingly adding keywords to every article, and then creating this ontology and mapping it and maybe revising it every few years. And we've done this for the medical enterprise. We basically try to fit symptoms and diseases and the manifestations in some kind of ontology. And every few years we have to throw it all away because we realize that didn't quite match. Well, this system is able to now map this ontology automatically by understanding the large language model itself, by understanding how that model represents these ideas internally, by being able to peek into the neurons of the machine, and by understanding how the machine conceptualizes every single one of these articles, taking these coordinates in this high-dimensional space and mapping them into a human navigatable form, we can project that in 2 dimensions, we can project that in 3 dimensions, and we can let humans navigate that landscape. So we can do the same thing for dozens of applications. So what I showed you in the previous slide was how we can do this for articles from the New York Times. Here on the top right, I'm basically showing you how we can do this for every paper written by MIT authors and every grant that was obtained by the same MIT professors. And you can now map one on top of each other as different floors of this 3-dimensional landscape. And at the bottom, what I'm actually showing is the actual physical space at MIT, right here on campus, where these papers were written. In the middle, I'm showing you how knowledge changes over time. You can basically look at the field of quantum physics and scan a temporal bar to basically see how that knowledge has evolved. On the top right, you can basically take loans, 100,000 loans, and you can basically see how do they fall on this landscape. Maybe when I should be evaluating every loan, I shouldn't be thinking of them in isolation. I should be thinking of them in the context of all of the neighboring ones in order to have a much more accurate assessment of what is there. On the bottom left, I'm showing every class at MIT and the link of prerequisites between them to basically understand how a student can navigate that space. On the bottom right, I'm showing you our own team's collaboration notes. Every single time a student presents, we record that meeting and we can now map that meeting in the space of ideas. Why are maps important? Maps are important because they give you a sense of the landscape, of the land masses, of the landmarks. They give you anchor points and street names or highway names. I challenge you to go skiing without a map. What does the map give you? It summarizes the landscape. It gives you an abstraction of that landscape. And it allows you to make decisions about where to turn based on that landscape. That's exactly what we want a cognitive landscape to have. We want to define clusters de novo. We want to create ontology terms and categorization completely from scratch for every new space. Understand the hierarchy, the abstraction, the collaboration capabilities of that space. We want to see both the trees and the forest. We want to enable contours and enable this topic classification. We want to see quantitative matrix, for example, the number of views that a video had, or the amount of funding that a company raised, or the number of patents that a professor generated or that a paper led to. We want the temporal components. We want to enable microlinks. Microlinks enable not just the landscape itself, but within a document, you might have multiple topics, and there might be small links between those topics to each other. Again, do not leave serendipity to chance. We want to enable these automatic discovery of connections that we might otherwise miss. We also want to enable a chat feature that works within the context of that space. We want to provide ways to save information for the next person who goes through that forest, for geocaching, if you wish, within the space of ideas. We want to enable multiple members of a team to all collaborate together and navigate the space together. For example, we have to review 300 applications for our conference. Let's let loose 20 reviewers in the same space simultaneously, and they can sort of leave notes to each other, turn on video when they're looking at the same set of documents or the same cluster. So that's what we have enabled. All of that are features of our space, which we call Mantis. But what's really exciting is that when we show it to creators of this content, they tell us, oh my goodness, this is exactly how I was thinking of this space. So there might be something there. Maybe the experts, when they understand the landscape of ideas within their field, maybe they're not doing it differently every person from the other person. Maybe there's something inherent to the way that humans understand things that come from the properties of language that are not very dissimilar to the way that knowledge is encoded within these large language models that, again, work based on context. And in fact, there's a study that just appeared that tells us that if you look at the MRI scans of people as they're thinking about different ideas and you cluster them, they cluster in exactly the same way that the large language model clusters the same ideas. So we may have hit something there about an underlying feature of human language that many of us share without actually realizing that we do so. The concept that we are now drowning in data, but there's no knowledge that comes of that data, is not a new one. And this whole concept that we are creating a world where we might not be fit reminds me of this cartoon with Dilbert back in the 90s, where Zimbo the monkey has a tail and suddenly can use a mouse much better than humans. And he says, it's your mistake. You created an evolutionary niche where having a tail is an advantage. That's what we have done with AI right now. We have created this unordered landscape of data with no map. And the AI is doing fine without a map, but we are suffering and we are feeling left out. So we want to enable humans to enter that space. We want to peek inside the brain of the machine and then start peeking inside the brain of a human. We can see what is Elon Musk thinking about by mapping his tweets. And you can see there's a big chunk about family collaborations, about media bias, about war, about Tesla, and so on and so forth. And you can do this for every person. You can do this for every collaborator. You can do this for every concept that you want to map. You can take your social network, and you have thousands of connections on LinkedIn. How do you organize them? If you want to organize a salon or a party or a conversation on a particular field, how do you even find these people? Well, you can map them in cognitive space and automatically discover these clusters. You can do the same with scientific papers. As I mentioned earlier, you can navigate this space of papers. You can blend the different modalities, as I showed you earlier, with the multiple floors. You can also start using the same way that you would use File Explorer in your computer, if your files were well organized, to basically see in a hierarchical fashion what are all of my folders related to each other. You can do the same thing in conceptual space. You can do the same thing to now start searching, not just a single giant search like Google gives you, but instead a topical search, where if you search for a particular topic within Lex Friedman's podcasts, it basically gives you a cross-cutting view that allows you to now search within each of these spaces. And what's really exciting is that you can now use contextual AI. Instead of asking the large language model to answer based on everything under the sun, you can basically say, well, within the set of documents that I just found, can you tell me answers about those specifically? And you can see here the chat function in practice. You can also, instead of just relying on the results of a search, you can select within the landscape, I want this hill and that hill. So if you're an undergraduate student interested in solid state versus quantum physics versus particle physics classes, you can circle them and then say, which one would you recommend for a junior with very little physics experience? And it will basically look at that specific space and give you back the answers in an organized fashion.
Let's either wrap it up right now or we'll record the rest later in the end of the evening.
So you can use that to explain the paths. You can use that to understand how grants fit with papers, with patents and drugs. You use that to track meetings and deliverables. You can use that to map documentaries. You can use that to map the bias in different media, to find recurrent topics in a podcast, to understand loans, investment, and backing, to understand education and training, to map the space of knowledge as it changes, to create immersive experiences as you navigate this landscape for students to learn different topics interactively by being players within these topics. And you can use the same thing to map proteins, to map patients and pathological variables, and you can use this to map every TEDx talk. You can see how does this very talk fit in the landscape of every TEDx talk. And this is exactly what we've done. We've basically pasted the description of this talk, and you can see us zooming in and out in the space of all other presentations. So we want you to join us on this journey. We're looking for cartographers that seek to map spaces. We have a fully working system, and we're looking to collaborate with you to start using it and change the face of how we understand the landscape of data and the landscape of ideas.